So this question came from a learner who's in Algebra 2, and she said, we're working on parabolas, and I'm just not sure if I'm doing this right. She said, I'm pretty sure there's a formula I need to use, and I'm just not confident, is what she said. And so we worked on some problems like these, and so I think they're good ones for us to look at as well. So I'm going to share it with everybody in the Q&A this week. So this is a function that is in what's called standard form of a quadratic. Ax squared plus bx plus c equals y. And so when you're in standard form like this, you are going to use a little formula, negative b over 2a. That's going to help us define the vertex. The vertex is where the graph changes from going downward and begins starting to go back upward. You know that if you're in an x squared equation, you know it's a parabola, but it's got that little U shape to it. So it's either opening up or it's opening down. And we know this one's actually opening up because the a value is positive, the 2. That's positive 2. That means it's going to open up. It's not going to open downward. So we already kind of know generally what the shape looks like, but let's find out where it is on the graph. So negative b over 2a. And the nice thing is these are in order. A is 2, b is negative 12, c is 17. So let's plug into the formula. So negative b, and b is negative 12. So negative 12 is positive 12 over 2a. A is 2. So we have 12 divided by 4, which is 3. So the vertex is 3 something. So I already know kind of where my line is going to be. So I'm going to go ahead at 3. I'm going to put a yellow like highlight line kind of here. Now, usually if I was on paper or if I was better with my marker here, I would use a dashed line, just so you know. This is typically a dashed line, but that's our what's called axis of symmetry. Sometimes you'll see it written AOS, and it's a line at x equals 3, and it's saying this is where half the points of the parabola are on one side and half the points are on the other. So, all right, let's find the rest of our vertex. So the way that we're going to do that is now we're going to go back to the equation and we're going to substitute because these were x values from the vertex, or this was the x value of the vertex. So I'm going to go back to 2x squared minus 12x plus 17. And where the x's were, I'm just putting parentheses and I'm going to put the value of the vertex for the x coordinate, which is 3. So now I'm ready to just see what this equals. 3 squared is 9. 9 times 2 is 18. 12 times 3 is 36. So 18 minus 36 plus 17. Well, 18 minus 36 is negative 18 plus 17 is negative 1. Okay, so the rest of my vertex is negative 1. If you use a calculator for that, then that's what most algebra students are doing. That works. So you can do that. So I go to 3, negative 1, which should be on that axis of symmetry if you've done it correctly. And we're going to plot the point. Okay, so now we have our vertex. So there's a couple of ways to sketch the rest of this graph. And I'm going to use something that I haven't really done in the past. I'm going to pick 2 easy points that are close to this vertex on the x-axis. So for this, I'm going to pick 2 and 1. So what we're going to do is go back to the equation and we're going to see what 2 is. Whoops, I wrote x. I meant to write parentheses there. And we're going to see what 1 is. So I'm going to put a 2 in here, and then I'm going to do it again and put in a 1. And I'll show you why I'm doing it this way in just a minute. Okay, so this is 4 times 2 is 8 minus 24 is negative 16 plus 17 is a positive 1. So that means that there is a point at 2, 1. I plugged in 2 and I got 1 for an answer. So 2 up 1. And then 1 squared is 1 times 2 is 2. 2 minus 12, that's negative 10, plus 17 is 7. All right, so there should be a point at 1, 7. So right 1 up 7. Okay. All right, plotted those 2 points. Now I have one side of the parabola. I need the other side, and it's going to be a symmetric mirror image. So if I, from here, if I go left and up 2, I can go right and up 2 and be in the same place. And then one more over should be up at 7. So one more to the right should also be up at 7. And there I've got symmetric points, on either side. So that's why I picked these 2 points. They were just going to be close by and easy to figure out what's on the opposite side that's in the same position. So now your goal is to connect the points and extend through with an arrow on both sides. And you want to make it a nice little parabola, prettier, than mine, I'm sure. In fact, I can let you see the nice proper one here. There we go. The red one. Let's see if I can erase mine. So that you can kind of see that. Oh, I didn't mean to erase all of that. And there we go. Okay, so the red parabola there, you want to make it kind of curved. You don't want to make it a V at the bottom. You want it a little bit curved. And that's it. That's sketching the graph from a quadratic function. Hope it helps. See you next time.